Welcome to Akhand Vidyashram, the first institute of impeccable wisdom, the walking, talking encyclopedia. Erythropoiesis, red blood cell formation. My mission, the impeccable wisdom, knowing which everything is fully known. My greatest discovery, Divyank, the divine design of nature with which the perfect objects are designed and created. Divyank is a reward of 60 years of integrated education. Impeccable wisdom is enlightening, and integrated knowledge is empowering. Let's understand the red blood cell formation, erythropoiesis, how it is formed from the time we are conceived. Let's take hematopoiesis or erythropoiesis. From the time ovum and sperm are fused together to form zygote, things start happening for developing the human body. The intrauterine red blood cell formation, it can be divided into three components: first trimester, second trimester, and third trimester. What happens during the first trimester? You have a mesoblastic stage, which is a nucleated RBC. Nucleated, not non-nucleated. Mesoderm yolk sac is the source, and intravascular erythropoiesis is the subject. So from that angle, you can understand what is actually first stage of erythropoiesis. Second stage, start hepatic stage, yolk sac is over. It also is a nucleated RBC. It's a mesenchyme, blood vessels and tissues in which red cells are formed. You can see in the picture very, very clearly liver and spleen right in the middle as the fetus is concerned. And by the time the child is born, this particular stage is over. At the end of the first trimester, during second trimester, third stage start developing, and that is called myeloid stage, non-nucleated RBC. Now, matured RBCs do not have nucleus. Nucleus has been completely absorbed. And it takes place in liver from bone marrow, and that is what is very, very clear. From that angle, there is no confusion. But now, as we start developing thereafter, after the birth, focus from digital, distant long bones start shifting to the axial bones, which are the core bones in the body. And that is called myeloid, non-nucleated RBCs. From peripheral to axial bone marrow, this is what is happening in the formation of red blood cells within the human body. So it can be called four different stages. First stage, mesoblastic, nucleate. Second phase, hepatic. Third, myeloid. Fourth, from peripheral to the core axial, and done with it. Having understood this, let's move on to the next. Red blood cell formation. The process of formation and maturation of red blood cell is called erythropoiesis. The different stages of erythropoiesis are proliferation, differentiation, maturation, release, functional RBC, senile RBC, and killing in 120 days. This is the usual process with which it goes. Bone marrow, medullary erythropoiesis, liver and spleen are extramedullary erythropoiesis. So let's leave it at that, and at the end I have said there are 10 stages of erythropoiesis, which we are going to develop it now one by one to understand what exactly is happening from germ cell, which is pluripotent, totipotent, from all the cells are developed. From there, how the things develop is something which we are going to go through to understand how erythropoiesis, the formation of red blood cell, is a perfect example of Divyank, the divine design of nature, which revolves around three centers. 22 by 21 to the power of 10. Let's stick into this. The third will be a little difficult to dissolve as far as the maturation, the last stage is concerned. Let's not get into that. 20 by 21 to the power of 10 is something which is very clear with erythropoiesis, the red blood cell formation. Now let's explore it. The first stage of creation of red blood cell formation comes with pluripotent, totipotent, all the cells from which everything is originated. This size is large, 21 micromillimeters or 21 microns, is found in bone marrow. Shape is irregular basophilic cytoplasm. Large nucleus, limited cytoplasm, proliferation to reproduce extensively, can form any type of blood cells, and original number remains intact for future cell formation in the bone marrow. If this is understood clearly, I think you will have no problem whatsoever to understand how things are going to go and learn to understand how the development is taking place within the body of the formation of red blood cells. At this juncture, I will also like to put across very clearly, red blood cells are specially designed to make sure that we can absorb oxygen from nature and develop into the fluid form along with the blood taken to all the 100 trillion cells to be given all the oxygen required for Agni or the fire or burning. That is very, very clear from this side. So, blood transformation of cells into a specially designed cell where nucleus is lost, and what is lost and how it is lost, we are going to see it step by step so that we can understand the real beauty of red blood cell formation. So, totipotent, pluripotent stem cells are the ones from which all the hemopoietic cells originate. Growth inducers are growth and reproduction of different stem cells are controlled by multiple proteins called growth inducers. There are four major growth factors. Interleukin 3, IL-3, this promotes growth and reproduction of virtually all types of committed stem cells, whereas others induce growth of only specific types of cells. Colony stimulating factor 3, Illinois 1, Illinois 6, they are the growth factors and hormones. Now, what are the cells to be understood as far as hemopoietic is concerned? You have RBCs, red blood cells, you have WBCs, and you also have platelets, and you also have other cells which also play an important role in developing different types of immunity or hormones otherwise. We will not go into detail at this particular juncture. Let's move on to the next stage of the first stage of development. First stage of creation is 22 by 21. Pluripotent stem cell, shape irregular, size is 21 microns. Volume or pluripotent is equivalent to 900 cubic microns. That is something which I want you to understand. 21 into 21 into 1.7 is 900 cubic microns. Cytoplasm is basophilic blue color. Nucleus is large, as you can see. Hemoglobin is not there. Function is proliferation. The size increases to 2 microns in that particular stage. This is the first stage of creation, which I can relate it to 22 by 21 to Brahma, the first stage of creation, or what Lord Brahma stands for. He is the Lord of creation, generation. So God, generator, operator, dissolver. So Lord Brahma is generator or creator, and that is 22 by 21. You can see in this particular stage very, very clearly. Second stage of development, you can see the colors is slowly being from being very irregular is becoming a little more qualified. It is called committed progenitor. Shape is irregular. Size is 21 microns. Cytoplasm is basophilic blue color. Nucleus is 12 millimeters of nucleus. Hemoglobin, no. Functions the differentiation. Size increases to 22. You can see the size developing to 22 microns at this particular stage itself. 21 has become 22. So let that be clear that this particular stage of committed progenitor, it is 22 microns. Third stage of development is burst forming erythrocytes. Shape is irregular again. Size is 20 microns. Cytoplasm is blue, basophilic blue color. Nucleus is active mitosis. Function is differentiation. Hormones are erythropoietin. They start now coming to play a role with the development of differentiation to the higher levels of functioning to become from gross cells like every other cell to a specially thing which can carry only oxygen for to be utilized by all the cells of the body for survival. That's it. Fourth stage of development is the colony forming erythrocytes. Shape is irregular. You can see it. Size is 18 microns. Cytoplasm is basophilic blue color. Nucleus is active mitosis. Function is differentiation. Hormones are erythropoietin, vitamin B12 and folic acid. At this particular juncture, vitamin B12 and folic acid plays very important role to make sure that we have 5 million cubic millimeters of blood in undiluted blood. From that, erythropoietin, B12 and folic acid should be absolutely essential without any issue at all. That is to be kept in mind. Fifth stage of development is pronormoblast stage and the shape is irregular, you can see it. Size is 16 microns. Cytoplasm is basophilic blue color. Nucleus is active mitosis. Function is differentiation. Hormone erythropoietin, vitamin B12 and folic. Those things continue to play an important role in fifth state also as we start developing to better quality of formed red blood cells. Sixth stage is a basophilic, the early normoblast stage. Shape is irregular as you can see. Size is 14 microns. Now you start seeing that shape is irregular. Size is reducing from 21 increasing to 22 and then slowly reducing by 2 microns at every level. Cytoplasm is basophilic. At this particular juncture, let me also make it. These are the values created based on Divyank, not what has been given by everybody else. I do not want anybody to be confused with respect to the kind of different things we have. We are creating an impeccable vision, knowing which everything is perfectly known, not the variety of disease models which can be done by the doctors and others at a later date. Let's talk of the perfect human anatomy, physiology, biochemistry and psychology. From that angle, this is what would be my thing. Now, basophilic earlier normoblast stage, you have cytoplasm which is again basophilic and this is because of RNA, not DNA. Ribonucleic nucleic acid, that is what it is. Nucleus is active mitosis, function is differentiation, hormone is erythropoietin, and then you start seeing ribosome synthesis in that particular stage. Now you are developing to the next stage to form hemoglobin one by one. So having understood right up to sixth stage, you still have a basophilic RNA, you have irregular 14 and differentiation is taking place. You still haven't come to the stage of formation of hemoglobin to be perfect whatever it is. Now let's go on to seventh stage is polychromatic intermediate normoblast stage. Now you can see shape is becoming irregular to more regular. Size is 12 microns. Cytoplasm is multiple color. It's no more blue color. You started seeing other colors. Poly mean many colors can be seen. There are multiple colors in cytoplasm. Nucleus is active mitosis. There is no nuclei. Cell division stops. Iron, copper starts getting in. As a result, hemoglobin synthesis starts specifically at this particular juncture is something which I want every student to remember. It is the seventh stage of development in which hemoglobin starts forming systematically, step by step, to the extent that it can replace the nucleus by hemoglobinuria. At this particular juncture, let me also tell you, every cell, if it is 100%, water will be 61.8034% and solid will be 38.1966%. Since every cell cannot have more than 38.1966%, so that means if nucleus is there, if it is going to be replaced by hemoglobin, and hemoglobin carries 35% of the solid matter for the cell. That means you don't have space for nucleus and most of the other mitochondria which have been dissolved in the process. That is also something which I want you to understand very clearly, how nucleus is removed and you form to non-nucleated RBC, and more of nucleus is into formation of hemoglobin, and other things are also reduced one by one so that you can understand what is required for the next stage of development. So having understood seventh stage, polychromatic intermediate normoblast stage, where hemoglobin starts appearing, by this time erythropoietin has played its role, folic acid has played a role, B12 has played a role, iron has played a role, copper has played a role. Now you have come to very specific thing. Now you can develop into something which is very specific. Eighth stage of development is orthochromatic late normoblast stage. It's the third stage of normoblast stage. Shape is regular, you can see it. Size is 10 microns. Cytoplasm is becoming red color, not blue, not polychromatic, but it's becoming red color. Nucleus, no active mitosis is seen, no nucleus seen, cell division has stopped, and maximum hemoglobin is formed by 8th stage itself of orthochromatic late normoblast stage itself. Having understood this and the role played by all the essential things in the formation of hemoglobin is to be understood, appreciated, and kept in mind. This will be the sequence which is going to make you understand each and every aspect even at a later date. Ninth stage of development is reticulocytes. Shape is regular. Size is 8 micron. Cytoplasm is more red color. Nucleus, no active mitosis, no nuclear, no cell divisions, maximum hemoglobin plus. Fine reticulum is seen in this particular thing, as a result is called reticulocyte. It is not called, and by this time formation of mature RBC has come to a more or less a final stage and appeared from in the bone marrow into the blood circulation at this particular juncture. It moves into this particular stage, and irregular has become regular, size has become smaller, it's more concise, more red, more towards developing the further division. 10th stage of development is the final mature erythrocyte stage, and shape is biconcave, means both the sides is concave, inside in the middle. Size is 7 microns. Cytoplasm is fruit red color. Nucleus, no active mitosis, no nuclear, no cell division, maximum hemoglobin plus, full maturation, and volume has become 90 cubic microns. But now you would have seen what was in the first stage, 900 cubic micron has become 90 cubic micron. That means it is divided by 10 times. That's something to be understood. What was irregular has become regular. What was blue has become red. What was the nucleus has become hemoglobin. And what are the things required to form per mature RBCs? I think we have gone through each one very, very clearly. Now, having understood that, now let's come to another stage to see the real beauty of these 10 stages seen very clearly in this particular form. Now, I have divided into two components. 10 stages of reticular development, which I told you in the beginning. You can see the same picture, and also something which is very specific. Let's take the pluripotent stem cell, which is irregular blue large nucleus, 25 microns. Comative progenitor, irregular blue large nucleus, 22 microns. And this is talking about 22 by 21. From there, it starts developing and reducing the size to come to 7 micron. Burst forming erythrocyte is irregular blue active mitosis 25 micron. Colony forming erythrocytes, circular blue active mitosis 18 microns. Pronormoblast is a circular blue active mitosis 16 micron. Early normoblast basophilic RNA differentiation 14 microns. Intermediate normoblast polychromatic no mitosis 12 microns. Late normoblast, orthochromatic hemoglobin starts, 10 microns. Reticulocyte, fine reticulum, red plus hemoglobin plus 8 microns. Erythrocyte, the mature biconcave, deep red, hemoglobin plus plus and 7 micron. These are the 10 stages which I want everyone to understand ki this is what it is all about. And once everybody understands ki at every stage of development, maturation, and finally it is 10 stages, you're going to see that every stage, and that's exactly what I've been trying to say from the first video to this stage, the 10 stage development, and that is what 10 incarnation of Lord Vishnu are all about. Now, there are few specific things which I would like to bring in this particular. Size changes from 21 microns to 22 microns during first stage. Size reduces from 21 micron to 7 micron 3 times over a period of 21 days. Volume of stem cell is 900 cubic microns. Volume of mature cell is 90 cubic microns. Reduction 10 times in volume. Shape changes from irregular to biconcave. Blue stem cells turn into red cells. Each cell gives rise to 10,000 red blood cells. Duration red blood cells last for 21 days. And all these are divine coincidences and things. At the same time, I'll also try to bring it that blood RBCs remain for 120 days is one part. Now, a few more things which I like to add is nucleus is replaced by hemoglobin, cannot be more than 38.2%, so it has to be 35% hemoglobin is done that way. Mitochondria is also reduced from this because oxygen is going to carry oxygen for the cells. If it start consuming for their own use, they will not be able to deliver. That's what this is also reduced. There are many interrelated questions of this to be met because they cannot manufacture new things. They cannot keep evolving further from the time they are manufactured. Within 21 days, they're fully formed, and then 120 days they live, and then they die, go to spleen, and go for erythropoiesis and break down and materially used again for the further formation and done with it. From that angle, let me tell you, that formation of red blood cell is the most beautiful example of Divyank, where you can see millions and millions of cells being formed every minute, and you can study and differentiate and done. And this is the result of my 60 years of research into this, from what I started way back in 1968-69 to this is almost more than 50 odd years. And that is what I've seen, and I'm just saying this is what I want every medical student to understand. This is real science. This is a perfect anatomy, perfect physiology, perfect biochemistry, perfect psychology, and that is that we can make optimum use of life completely once for all. Last stage, let's not talk about it. I think I've already spoken about it. At this juncture, let me say it has been wonderful sharing my experiences of 60 odd years beautifully for the love of the world and giving it to the world in the form which should have been done thousands and thousands of years ago. But anyway, it's never too late. Now we can start rectifying and bring it to perfect and start from school, college to the university throughout the world, knowledge which cannot be found fault at all. So from that angle, it has been lovely talking to you. Thank you very much. Thank you.